So for some of us, we may have difficulty in placing some of the boxes on the topography where they might hang out too much over the topography and they're falling in, and you want to figure out how to place some more topography underneath them. We've done a little quick example for you guys here so you can think about. After having looked at a lot of the exterior zoning areas, for example, if the student right here had difficulty, they wanted to express this box on top of the living room, but it ended up, the topography wouldn't support the bottom, then we just went ahead and placed a deck. So there's no reason why we can't place a deck, and we were just very careful, and when we place the deck, make sure it doesn't necessarily perfectly align so it looks like it's actually in the same language as the top boxes are, where there's a slight offset, but then you can still read the entire geometry. So that's just a quick example. I'll show you how this was previously. It just ended up being like this, where, oh my God, we really can't place the building up in the air. Instead of manipulating the entire topography and pushing it out to make more topo, decided just to place some decks underneath them. And it works, right? So all of a sudden this bedroom has its own private deck that you may walk out onto, like this guy just did. And this person just happens to have a planter, perhaps. The planter maybe provides a little bit of privacy between this deck and this deck. That's something you can think about, and you as the designer, you could manipulate that and work with it. Made the decks in this scenario 2 foot 8 inches tall, just to be consistent with the topography. There are many ways to do this, and here's a reverse example where the deck is actually carved down into the topography as opposed to raised from it. Here's a living room, for example, and it sits slightly submerged into that topo and sits flat on this one right here. And just identified it by sinking that deck so it's flat with the topo here, and it generates maybe a little bit of wall around it. And then when you look at it from the top, you actually have the similar geometry as you may have with the buildings themselves. So you may look at that roof that's offset from that roof, and then the deck itself is offset as well. So there's a consistent geometry going on with the things colliding to each other. This planter, for example, collides into the deck right here. So there's a little bit of consistent language which works for us, and the planter itself isn't, the end of the planter is not coplanar with the edge of the deck either, right? Because we said that two surfaces that are close to each other should never be coplanar. They need to be offset vertically from each other. So here's a little quick example. This was just a really quick one, and it doesn't necessarily mean yours will look exactly like this. You will design yours, and you would maybe converse with your design instructor and go from there. In this scenario, these guys are just are slightly hanging away from the deck, and that's possible. Not the entire building has to be resting on the ground, but if it was resting, but if it was that much off, then there's a problem. Yes, this will fall. Okay, but having it stick out just a little bit is quite all right. Too much? No. So just a quick example on how you might place decks that might help you raise some buildings that you might have trouble with. Okay, hopefully this will be helpful.